Welcome to Algebra, multiplying binomials using the FOIL method. In the last lesson, we revisited the distributive property first introduced in an earlier lesson and used it with expressions like this, distributing the x term to both inside terms, resulting in x squared plus 5x. We now expand this idea to multiply two binomials together, an extension of the distributive property, multiplying the first terms of each binomial, x times x, to get x squared, the outer terms, x and 5, resulting in 5x, the inner terms, 6 and x, to get 6x, and the last terms, 6 and 5, to get 30. The two x terms, 5x and 6x, combine to equal 11x, and the final result is x squared plus 11x plus 30. It is called the FOIL method since the letters F-O-I-L spell out this acronym, representing the first terms multiplied, then the outer terms, the inner terms, and the last terms. This FOIL process will be used a lot in coming lessons, and so you need to practice it and master it. Let's try another one. Multiplying the first terms, 2x times x, makes 2x squared. The outer terms, 2x times 3 equals 6x. The inner terms, negative 5 times x, is negative 5x. And the last terms, negative 5 times 3, makes minus 15. Combining the middle two x terms, 6x and negative 5x, results in just x, and the final result is 2x squared plus x minus 15. Here is one with two subtraction binomials. We multiply the first terms, 3x and x, to equal 3x squared, the outer terms, 3x and negative 4, to equal negative 12x, the inner terms, negative 2 and x, to make negative 2x, and the last terms, negative 2 and negative 4, to equal positive 8. Combining the two middle terms, negative 12x and negative 2x, equals negative 14x, with the final trinomial resulting in 3x squared minus 14x plus 8. An application of using the FOIL method to multiply two binomials is when each is the dimension of a rectangle, like this one, and we need to find the expression for the area of the rectangle. A rectangle is shown with dimensions 5x plus 4 and x plus 3, and we use the FOIL method to multiply the length times the width, and achieve a trinomial expression representing the area of the rectangle. Here is another example, a rectangle with dimensions 6x plus 5 and x minus 2. Following the FOIL method, we multiply the first terms, the outer terms, the inner terms, and finally the last terms. Combine the two x terms and achieve a final result representing the area of this rectangle. It is also possible to have a binomial multiplying a trinomial, where the FOIL method is extended in a similar way, with the first terms multiplied, resulting in 3x cubed, then the first times the middle, making 2x squared, and then the first times the last, the outer terms, equaling negative 2x. The same thing happens using the second term of the binomial, multiplying each term in the trinomial, 3 times 3x squared equal to 9x squared, 3 times 2x resulting in 6x, and finally 3 times negative 2 to make negative 6. The 3x cubed term leads the final result, with the two x squared terms combining to make 11x squared, the x terms combining to equal 4x, and then finally the constant negative 6 at the end.